Hi, let's take a look at some more examples of expanding and simplifying polynomials. So example 4, we are multiplying the two binomials, 2x plus 3y, x minus y. And then we're multiplying monomial 4 by x minus 2y raised to the power of 2 plus 5. And then we have the binomial x squared minus y squared. So let's get started. So we're going to start off with this multiplication first. So what we have here is 2x times x, 2x squared. And then 2x times negative y is negative 2xy. 3y times x, positive 3xy. And lastly, 3y times negative y, negative 3y squared. So this would be just the first part, or the first multiplication. And then we'll continue with, let me resize this, the next multiplication, which is 4 times x minus 2y squared. So we're going to leave number 4 outside the brackets first, and we'll take care of the power of 2, and that's because of the famous BEDMAS rule. Now, remember that when we expand a plus or minus b to the power of 2, the answer would be a squared minus 2ab plus b squared. So we've learned this in grade 10. And we are going to expand x minus 2y to the power of 2, following the same pattern. So we're going to have the first term raised to the power of 2. That means x will be to the power of 2. And then we'll have double the product of first with second. So double the product of x with 2y. So x times 2y. Now remember that the negative sign is carried over right here. Okay, and lastly we have the second term raised to the power of 2, so b squared. In our case we have 2y squared, and 2y squared is 4y to the power of 2. Close the brackets, and that would be our second expansion. Let me just minimize this. And lastly, we have 5 times x squared minus y squared. Now you probably recognize this is a difference of squares. So in this case, we're simply expanding, multiplying by 5. So we'll write in here plus 5x squared, and then minus 5y squared. And at this point, we're ready now to collect like terms, almost. So besides this part of the expression where we are multiplying by the monomial negative 4. So let me bring this a little bit further here. Okay, and here we go again. So we have 2x squared. Now remember 2x squared here, 5x squared here, plus 5x squared. So let's group like terms in the meantime. Now, minus 2xy plus 3xy, these are like terms because they contain same variables raised to respectively same powers. So you just work out the coefficients, negative 2 plus 3, which is 1. So we have 1xy. We don't have any other xy terms for now. So lastly, we have the y squared term, and we have another y squared term here. So they're like terms. So negative 3 minus 5 would be negative 8y squared. We'll continue with this expansion. So negative 4x squared. Remember, negative 4 will multiply every term inside this polynomial. So we have negative 4x squared. Now remember that this will simplify to 2 times 2, 4xy. So negative 4xy multiplied by negative 4, that's positive 16xy. And then negative 4 times 4y squared, negative 16y squared. So in the next step, we're going to group like terms again. Let's see what we have. So we have x squared terms. And going to simplify the x squares first. So we have 2 positive 5 minus negative 4, so that means 7 minus 4, 3x squared. Now, xy terms, let's check and see what we have in here. We have 1 xy here and 16 xy's in here. We have 17 xy's. And the y squared terms, we have negative 8y squared minus 16y squared. We have negative 24y squared. And this would be the most simplified form of this particular expression. Okay, so in the next question, we have again something similar, but as you can see, you see the presence of square and round brackets. So remember, the round brackets are considered to be the inside brackets, which means that we would first have to identify what you have. So what you have in here inside the square brackets is an expression, which means you need to simplify this first. So this has priority. And then once this is completely simplified, then you can multiply it by 3x minus 5, the binomial. So let's get to work. We're going to keep 3x minus 5 inside the brackets, so we're not expanding for now. And we're going to work the inside of the red brackets or square brackets here. So we have 3. Now remember that this number 3 is not multiplying 2x plus 4. It's a common mistake people make sometimes, assuming that, this 3 should go here. Please don't make that mistake. So we are going to continue with multiplication. Just follow BEDMAS rule, right? So multiplication first and then add number 3 at the end. Now, again, what we have in here is the product of these first two numbers. So that's 2x to the power of 2. And here we have 4 and negative 1, which is going to make the last term in the expansion. And then the middle term, we have to look at the sum of 4 and negative 1, which is 3, and positive 3, and that would be our x term. And next, we are going to simplify just a little bit more. And we have 2x squared plus 3x, and we have 3 minus 4 equal to negative 1. So now we are expanding. So we're going to take the first term in the binomial and multiply it with every term in the trinomial here. So multiply by this, and lastly by negative 1. And this will give 6x to the power of 3. Remember that x times x squared will bring x to the power of 3, and you multiply the coefficients, plus 9x squared minus 3x. So this is this part of the expression. And similarly, we will be multiplying this term here by every term in the trinomial, and that will bring us to minus 10x squared minus 15x, and then plus 5. And voila. Oops. Here we go. So now we are simplifying. You can collect like terms. You don't necessarily have to show the step. So 6x to the power of cube is going to be our highest degree term here. Now we're going to look at x squared terms. So it seems that we have 2x squared terms, which means 9 positives and 10 negatives will give 1 negative x squared. And then we have the 3x, negative 3x, and negative 15x, the x terms. So we have negative 18x's, and then plus 5, and this is the most simplified form of the expression. So next we're going to look at example 4. We're expanding and simplifying. This time we have included terms that contain fractions. So in principle, you do the same thing. Remember that when you multiply fractions, you would multiply tops to tops, bottoms to bottoms, meaning you're multiplying the numerators together, the denominators together. So we're going to start off with 2 over x, and it is multiplying every term in the second binomial. Now, if you notice here, there is a pattern as a matter of fact. So we're going to try to do this in two different ways. So you see that we have 2 over x plus 3x and 2 over x minus 3x. And if you remember from grade 10, it means that we have the product a plus b, a minus b, that results in a squared minus b squared. And we call this the difference of squares because we're getting as an answer the difference of 2 squared terms. So first, what I'm going to do is I'm going to simply use FOIL. And what we have in here is 2 over x times 2 over x, which will be 4 divided by x squared. And then 2 over x times negative 3x. So negative 2 over x times 3x. And next we have 3x times 2 over x. And lastly, we have 3x times negative 3x, so negative 9 over x squared. As you can see in here, these two terms are exactly the same. They have opposite signs, which means that the answer here would be 0, or they would simplify to 0. And the final answer would be 4 over x squared minus 9 over x squared. So if we were to follow the difference of squares formula, this would be basically the first term. This would be your a value, and this is your b value, so a and b. And that would be 2 over x squared minus 3x squared. And that would result in 4 over x squared minus 9x squared. And that's the same as the answer we got in the expanded form. Now the question is, how would you want to do this? Obviously, you expect you to do this in the more sophisticated, let's call it, way, but following the difference of squares formula would be the more efficient way of doing this. So in a similar way, you may want to try this, so you can pause the video if you wish. So I'm going to go ahead and use the difference of squares. As you can see, we have the exact same terms in here. Oops, and we have minus. So in this case, the formula that we are using, or the pattern that we see, is a minus b times a minus b. So this would be a minus b squared, which is a perfect square trinomial, so I correct myself. So a squared minus 2ab plus b squared. And we're going to take the first term, bring it to the power of 2, so x squared to the power of 2, minus double of the first term with the second term, and then plus the second term brought to the power of 2. Simplify, and we have x to the power 4 minus, so notice here we have x squared and x, that will reduce x squared to just x, so 2 times x times 5 will make 10x, and then lastly we have 5 over x squared, which will be 5 squared, 25 over x squared, and this will be the more simplified form of this expression. So next we're going to look at example 5, where we have to find an algebraic expression for the shaded area. So there are multiple ways of simplifying or finding the shaded area here. The one that I would suggest is we look at the total area of the rectangle, and then we subtract the white areas, so which are these little triangles. So first things first, if we want to find the area shaded as area of a rectangle ABCD, subtract the area of triangle BEF, and then subtract again the area of the triangle FGC. Okay, now we're gonna have to figure out what the dimensions are. So for the rectangle, you have length times width, and the length will be BC or AD, doesn't really matter. So you see that we're given BC 3x minus 3, we're given FC x plus 1. So that will make the length of the rectangle BC equal to 3x minus 3 plus x plus 1. So 4x minus 2. And then the width of it will be A to B, so that would be x plus 2. So the area of the rectangle would be 4x minus 2 times x plus 2. So next, we're going to look into the area of the triangle BEF. So area of a triangle is base times height divided by 2. Just going to write them down here for reference. So area of a rectangle is length times width. Area of a triangle is base times height divided by 2. So in our case, we have the base of this triangle, 3x minus 3. And then the height of this triangle would be same as the width of the rectangle, x plus 2 from here to here. And divide this by 2. And then we are subtracting this area right here. And we are given that the base is x plus 1, the height is x. And usually I like to keep the monomials before binomials, makes the multiplication feel more natural, divided by 2. And then all we have to do is expand and simplify. And here we go. We have 4x minus 2x plus 2. Very quickly, 4x squared. And then plus 8x, plus 8x minus 2x, 6x, negative 2 times 2, minus 4, and then minus. So we're going to expand the numerator first. So 3x squared. And now we have 6x minus 3x, positive 3x, negative 3 times 2 is negative 6. Divide this by 2. And then minus. Down here we have x squared plus x. Divided by 2. Now, as you can see here, we have the two fractions with same denominator, which means that they can join each other. And we're going to write this as 4x squared plus 6x minus 4. And minus, so we're going to rewrite the first fraction, 3x squared plus 3x minus 6 as is. And we will be subtracting this numerator from it. So we are subtracting x squared plus x. And I'm going to take an extra step here because it's very easy to make a mistake in here for when you are bringing this numerator over, and just because of the minus sign. Now, reminder that when you are subtracting a polynomial, more than one term, we have to take care of switching the signs, so modifying, adjusting the signs of every term. So usually people put the minus before x squared and forget the x in here. So just to be mindful of that. So we have 4x squared plus 6x minus 4, and then minus, keep that denominator of 2 there. And then we have 3x squared plus 3x minus 6 minus x squared minus x. And obviously we're going to need to simplify that a little bit more. And you can definitely do this in shorter steps for sure. We're just explaining this for today. And we'll have the like terms, 3x squared minus x squared, 2x squared. And then 3x minus x is positive 2x, and then minus 6 over 2. And I'm really happy that we got all these coefficients to be even numbers, because that will make it a lot easier to take out a common factor of 2. And then we have x squared plus x minus 3 divided by 2. And that will simplify our denominator. And we end up with, 4x squared plus 6x minus 4. And then again, remember there is a minus, so we are subtracting this whole expression, right? So that means that this minus will apply to every term inside the bracket. So we're going to have here minus x squared. So you see that you have plus x that will turn to, again, minus x. And lastly, we have minus negative 3, which makes this a plus 3. And one last step. We have 4x squared minus 1x squared. So we're left with 3x squared. 6x minus 1x is 5x. And negative 4, positive 3 will give negative 1. And this would be the shaded area. And to make this more professional, I'm going to give it a little bit. I'm going to give it units, so that would be units squared. And this would be it. So this is the end of lesson 1, part 2, review of prerequisite skills for the grade 11 functions course. Thank you for working with me. Bye for now.